A few last things you need to be aware of about these protocols. When you configure your controller, you will be configuring data rates or MCSs. And there are three categories of rates. Those that are said to be basic or mandatory. When you enable a rate to be mandatory, what your access point says is that your clients must be able to run that rate to be allowed to join the cell. Then there is what we call the supported or optional rates, which the access point says, I can do those rates. If you can do them too, fine, we can communicate at those rates. If you cannot do them, no problem. You don't have to do those. You have to do the basics, but these ones are optional. And you can also disable some rates on your access points where the AP says, you cannot use those rates in my cell, and I will not use them myself. Okay, so this is important because when you configure your network, you will see that some rates are mandatory by default. You saw the 2.4 gigahertz rates on the right, and in the middle, the 5 gigahertz rates. And you see several of them are mandatory by default. And if you look at those, you'll see that for the A rate, the 5 gigahertz rates, those are where you change modulation from BPSK to QPSK and then QAM. And the reason why they were mandatory in the original 802.11a specification is to make sure that any station that would get into your cell would understand all modulations, 16 QAM, but also BPSK and QPSK. And you would not have any station that would come in that would only be able to do BPSK. So these were in the old days, so these are defaults because they were what was described in the original amendment. Today, you can decide to set any of these rates to mandatory or any of these rates to disable because all stations that do A do all these rates. For the BG side, you can see that we have the B speeds that are mandatory, and then the G speeds are optional. This is again coming from the old days where B stations were there, and you may have some G stations coming on top. So B was mandatory, but G was optional. Today you can disable any of those because there is no station anymore that does only B, unless it's a very, very peculiar environment. However, keep in mind that your broadcasts are going to be sent at the first mandatory rate. So at least one rate has to be set to mandatory. And it doesn't mean if you do 2 or 3 rates mandatory that your stations have to communicate at these rates. It just means that your stations have to be able at some point to communicate, to modulate those rates. Not now, but at some point. They have the capability to do so. That's what it means. Doesn't mean they have to communicate at those rates. They can communicate at supported rate if they want to. But your beacons will be sent at the first mandatory rate, and all your broadcasts will be sent at the first mandatory rate. So one rate has to be mandatory. And typically it's the first rate you allow because the beacon is going to determine the size of your cell. So you want the beacon size span to be the same as the cell size. So the first rate you allow is going to be the mandatory rate. And then you may have some more mandatory rates if you want to, but at least the first one must be mandatory. Also, notice that we don't see any N or AC rates here, right? Those N and AC are always optional. Nowhere in the 11N or 11AC amendments do we have any description of these rates having to be mandatory. So even if your stations do N and AC, you'll be basing your mandatory ID on those legacy rates, at least today. So what about the speeds? Well, some frames are unicast and they are going to be sent at whatever your station thinks is best based on whatever signal was received from the access point. So each station for each frame, including the access point, is going to decide for its next frame to whatever, what speed should be used for that one transmission. So if you have many stations, you'll see many speeds in the cell from the AP and to the access point. And this is because you only care about one receiver, so you are going to pick up the best modulation for that one communication for that one frame. But however, once you have this choice made, there will be this internal algorithm that's going to be local to whatever sender is sending the frame, and that may be different on the receiver end. For the same signal, the receiver may be choosing another rate. But that decision is going to be made, and you're going to send a frame at some rate. Now, your receiver will have to send an acknowledgement frame. And the acknowledgement is a little bit more complex, right? Because it validates that you received the frame. So the algorithm already to choose the frame is complex itself because it's based on the signal level of the last frame you receive from the station you want to send to. And depending on the cell conditions, you understand that sometimes your choice may be wrong. So you may be sending a frame, and as you see here, you don't receive an acknowledgement. So you're going to retry maybe once, twice, and then there will be a rate shifting algorithm in the sender that says the frame is not acknowledged, so it's not received. Let me go back to some other modulation that may be stronger, and you may be downgrading, for example, from 72 to 65 here, and you try to send your frame again. So you see there is not only a vendor-dependent aspect of this frame transmission and data rate that is chosen, but also depending on the current conditions, how many frames you tried before, and how many of them succeeded or how many of them failed. That leads to something very important that may not be critical for your CCNA exam, but is going to save your life many times if you troubleshoot Wi-Fi. And that is that there is always, if you take two stations, and I'm taking in that example the access point and a station, but it's also valid from a station to the AP. So if you put the station at the center and the AP at the edge, or two stations communicating directly as well. So there are a few zones that you have to be aware of. There is what we call the coverage threshold for the rate at which you're sending. So if you're sending some traffic and there is a station that is at point 1 and you're sending say at 24, that is the point where the station receives the modulation at 24 megabit per second and has enough RSSI, enough SNR to be able to read and understand that 24 megabit transmission, and is going to be able to decipher that frame and understand it. Then beyond that point, there is another zone where you actually do not demodulate the frame anymore because you're a bit too far. So the SNR is a bit too low and the RSSI is a bit too low. Still, you understand that there is communication because you do receive a signal, but you just don't quite understand what the signal is about. So what happens? Imagine if you're speaking at the access point level and to a station which is very close and use 256 QAM, as we said before, which has a very short range. Many stations will be in area 2, right? Everything that is more than 10 or 15 feet away from the AP is going to be in that zone 2 type of thing because they do not understand 256 QAM. They are too far from you. So what happens? Well, the thing is, and this is going to be useful, is that there are two types of headers in an 802.11 frame. There is the Layer 2 header, the MAC header as we call it, and this is what we saw in the previous lessons where you have this frame control field with the 3 MAC addresses, etc. So that's what we call the MAC header. This part is sent at whatever modulation you are choosing and whatever speed you're choosing. So in my example, that would be sent at 256 megabit per second. But before that section, before that MAC header, there is what we call the physical header. And the physical header's job is to inform the receiver that there is a frame coming. Because if you are a station and you listen to the air at every slot time, you're going to hear energy all the time. And you have to know when that energy is supposed to be a frame. So there will be a physical header that will be containing a few things, and one of them is the preamble. That is a boom, 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 boom signal saying that there is some timer, there is some voluntary communication here that tells you that a frame is coming. And then there will be a section of the frame that you see described here with a PMD and PLCP header that is going to describe what is going to come after. And the key thing for you is that that physical header, PMD and PLCP, is always sent at the lowest possible speed, which means that if you send in 5 GHz, it's going to be sent at 6 megabit per second with QPSK. If you are in the 2.4, depending on what protocols you're using, it may be 1 or 6 megabit per second. And that is true even if you disable 6 megabit per second on your controller. That physical header is independent from the communication at the MAC layer. So it's independent from the configuration of your controller. So it's always sent at a very low modulation. And the great advantage is that it says two things of great interest. One of them is the data rate at which the rest, that is to say the MAC section, is going to be sent. 256 megabit per second in my case, 256 QAM. And then it also says the length of the communication. So it's not the length of the exchange, it's the number of bytes or the time that the transmission is going to last. And that field may be varying a bit depending on what protocol you're using. But this is an example with OFDM, but it's simple enough for you to understand what happens. And that means that even if you're in this area too, where you cannot read my 256 QAM and my transmission, you will still be able to read that physical header of the frame because it's sent at 6 megabit per second. So you're still close enough that you'll be understanding that there is a frame that is being transmitted. You will not be able to read the MAC header, so you don't know what the destination of the frame is, right? You don't know if it's for you or for someone else. But at least you know that a frame is being transmitted at 256 QAM and that the duration of the frame is going to be whatever duration. So at least that allows you to be quiet because you are below what we call the interference threshold and you know that somebody is sending, although you don't understand what they send. And of course, if you move away from the access point again, you'll get to that larger area, which is what we call the physical carrier sensing threshold, where basically you don't understand that physical header anymore because you're really too far. You do understand that there is some energy being sent, and from the pattern, you may be guessing that this is an 802.11 transmission, but you can't read the MAC header, and you cannot read the physical header either. So you just don't know what is being sent. You just know something is being sent, and you may not be sure that it's actually something that is concerning you, and you may be deciding to send yourself. And there, you may start collisions. And of course, if you are beyond that, well, you may detect some vague energy in the background, but it's just noise for you, so you ignore it completely, and you would not be in the cell anymore, you'd be sending. But if you're close enough to stations in the cell, you may be disrupting them, of course.